We get back to quadrilaterals. This past weekend, I did recommendations for where I thought everyone would be successful next year. I just want to remind you, your two choices for math next year are Honors Algebra 2 BC and Algebra 2 AB. If you are a ninth grader, both are still 1 year accelerated. All right, I talked about the difference in the courses before we went on break. So this past weekend in Aspen, I put my recommendation down. And again, I put a recommendation down where I thought you would be successful, not where you're going to be popular or what's going to look cool on your transcript, where I thought you would be the most successful next year. All right, so on your own time, not while I'm teaching today, please, on your free time later on today, get onto Aspen, take a look at what I recommended. If you have concerns about it, let me know, email me. If you don't think I made the right decision, email me and we can talk about it. Okay, please email me if you feel uncomfortable with the recommendation I made. Again, it is a recommendation. You and your family have the ultimate say at the end where you go. So if I recommended you for one course, but you think you should be taking the other, you can take that, fine. But I'm telling you what I think you'll be successful in next year. And in addition to that, if you would like to take computer science next year as an elective, all right, you can't take it in place of Algebra 2. It's an elective. If that's something that interests you, in computer coding, if that is something that interests you, email me and I can put that into the recommendations too. Okay, that's not a yes or no type deal. If you want that, if you're passionate about computer science, let me know. I'll put it in there. All right, guys? So that's the deal with the recommendations. I would love to sit down one-on-one with everybody and discuss them with you, but we're not going to have enough time because the recommendations are due, I believe, next Monday. So I'm not going to have time to do that. All right, but again, if you don't like the recommendation or want some further input, let me know. I'll talk to you. No issues. No issues. Over the break, I handed back your quad quiz to you. You should now have access to it. I'm going to go over any questions, and I'm going to go over the problems to those on Wednesday. All right, on Wednesday, I will go over any questions and certain problems on Wednesday. So make sure you take a look at it. And I do want to give you guys a heads up. We are going to have our quadrilateral quiz on Thursday. Okay, everyone's going to take it on Thursday. And I'm just warning you guys ahead of time, there's going to be factoring on it again. Very similar to what you did on your quiz. And I feel bad for some of you because some of you guys didn't take me seriously when I told you there was going to be factoring on the quiz. And it was pretty clear because some of you guys still had no idea how to factor from Algebra 1. So I'm telling you, it's on there again, along with how to break a radical down. All right, one of the questions on the test, I asked your answer to be in simplest radical form. All right, so again, like usual, I wanted to give you guys enough heads up and enough notice so I wasn't telling you the day before. All right? You guys have any questions for me before we start hitting the ground running with quadrilaterals again? Recommendations or the test on Thursday? Anything I can answer for you guys?
I know I probably asked about this last time, but it's, never mind. I'll just do it on my own.
Okay, it's up to you. So it's up to you. Okay, everybody good? Any other questions on these? Because I'm just going to start talking quadrilaterals now. Before we start the notes, I want to remind you guys, I would appreciate it if you paid attention to the detail of tonight's homework because it's just not on trapezoids. All right, I threw a couple square and kite questions in. So please make sure you either look at the assignment sheet I posted on Classroom or the actual assignment on Classroom. Pay attention to what page numbers, packet pages you have to do tonight because it's just not trapezoid stuff. All right, please pay attention to that. You should be doing some square and kite questions too. And that is exactly where we're going to start off today. We're going to start off with a kite question I did not get to the Wednesday before break. So if you guys could get to page 36 for me, that'd be great. Packet page 36, and go ahead and graph quadrilateral RSTV for me. We're going to start today's lesson off by reviewing properties of a kite. So go right ahead. Graph quadrilateral RSTV, and we'll get moving. Good to be back with each other. I'm back in the classroom and not on my kitchen counter, which is always good. All right, let's get this moving now. Prove this is a kite. A reminder, I have our kite drawn up here for you. A reminder of what a kite is. It does have more properties, but for this purpose, what a kite is and what you need to show me is it has two pairs of consecutive sides that are congruent. That's what you need to show me on this diagram here. If this quadrilateral is going to become a kite, you guys got to show me it's got two pairs of consecutive sides congruent. As you guys know, or if you remember, when you do a coordinate proof for me, the first step in the coordinate proof should be, hey, what formula are you about to use? What formula are you going to use in this coordinate proof? So if I need to prove consecutive sides are congruent, I'm going to need what formula here? Here we go. First one, coming back. 1-7. Here we go. Maeve, what formula am I going to need here to show two pairs consecutive sides congruent?
Distance.
There you go. So step one, I'm going to show that I am about to use the distance formula. X. Or if you guys use Pythag, write Pythag. A squared plus B squared equals C squared. So first step of a coordinate proof, show me the formula you're going to use. And just to put this into your head too, there is one coordinate proof on Thursday's unit test. There will be one of these. All right, one of these coordinate proofs. All right, step two, use it now. Use the formula you've picked. So we've decided to use distance formula. Let's use it now on all four sides. So here we go. Length of RS is equal to, now, we're in January now. If we can't use the distance formula property, we're in trouble. All right, to save some time, I'm not going to ask you guys to do it. I'm just going to do it for you and show you the results, because by now you got to be able to use the distance formula. So when you use the distance formula in RS, you get 1 squared, and then you get 5 squared when you do your X's and your Y's. So 1 squared plus 5 squared, we're looking at the square root of 26 for the length of RS, square root of 26. Let's keep chugging away. ST, doing the distance formula of S to T, we'd get 5 squared plus 1 squared, which is also square root of 26. And again, just saving us time by doing the distance formula for you. All right, next up, let's go to VT, distance of VT. Underneath the radical, you would have gotten 2 squared plus 6 squared, which, if you guys do that math right now in your head, 4 plus 36 would be the square root of 40. Now, let me stop right here and just make a comment. I realize that many of you could break down the square root of 40. I do not require that for a coordinate proof. Do not require it for a coordinate proof. And to be honest, I prefer you don't break it down, because if you do make a mistake breaking it down, I do have to take off for it. So in a coordinate proof, I would prefer that you do not try to break it down. You can, but I prefer you don't. So there's VT, square root of 40. VR, 6 squared plus 2 squared. After you do all the math, and yes, it comes out to be the square root of 40. Okay? So here we go. Number 3. I believe we just found out this was a kite, because what did we need to do? 2 pair of consecutive sides congruent. I got that. So RS TV is a kite because what we just talked about, RS TV is a kite because 2 pairs of consecutive sides are congruent. Don't put a period, though. Don't put a period to end it. Don't put a period. That is not a good enough explanation. This doesn't tell me that it's a kite. And I want to show you guys why I need to write a little bit extra here, other than what I've just wrote. Take a look at this figure here, this quadrilateral I have up on your screen now. Here's what you guys wrote. You said it was a kite because you had 2 pairs of consecutive sides congruent. Watch what I'm about to do. There's a pair of consecutive sides congruent. And so is that. In my diagram, didn't I mark 2 pairs of consecutive sides congruent? But what is this figure right here? That bad boy is not a kite. Somebody chime in here. What do we call this if all 4 sides are equal? It's got to be a what?
Rhombus.
Yeah. It could be from what you guys have just told me right here. 2 pairs of consecutive sides congruent. Well, it could be a kite, but also I'm showing you guys it could be a rhombus. So to eliminate the possibility that it's a rhombus, I'm going to have to add a couple extra words here. And no sides congruent. That eliminates the possibility that it's a rhombus and it's got to be a kite. So hopefully you guys understand why I need to write in that little extra portion and no sides congruent. Because if you stopped with 2 pairs of consecutive sides, that could be a kite or it could be a rhombus. So I needed to eliminate the possibility it was a rhombus.
I'm confused. It says no sides congruent, but we just said the 2 pairs of consecutive sides are congruent.
All right, you got me there. Let me get a little bit more detail now. And all sides are not congruent. How about that? All sides are not congruent. You got me there. I should have been a little bit more detailed. That's my bad.
Could we also say and opposite sides aren't congruent?
Yep, that's perfect. Yep. That also would eliminate that it's a rhombus. So all sides are not congruent and opposite sides are not congruent. That's perfect. I like it, guys. Good thinking. Anybody else here with the kite? So everyone all right? It's a little bit more than saying just the 2 pair of consecutive sides because you had to eliminate that it was a rhombus. Questions from you guys before I hit up the trapezoid?
Would we have to say that ST is congruent to RS and VT is congruent to VR in a separate
when you're doing the distance formula, Radhika, I really don't need stuff like that. It's really more for if you're saying 2 sides are perpendicular or 2 sides are parallel, have that statement in there. But when you're saying 2 sides are congruent, I'm not going to be picky. I can just look at your distances and see that you did that. Okay, good question. Anybody else? All right, so again, a reminder, you have square and kite questions tonight, in addition to the trapezoid, which we're about to start. Okay, do not forget that. It's just not all on trapezoids. All right, so let's go to page 39 now. Let's talk about the trapezoid. All right, you guys remember from the family tree, there's 2 types of trapezoids. There's just trapezoid, which is the first one I'll talk about. And it's not that great, let me tell you. It's not exciting, the trapezoid. The only property you have for a trapezoid, 1 pair and 1 pair of opposite sides only are parallel to each other. That's it. We're done with the trapezoid. That's the only property you have for a trapezoid. So I can tell you we're not going to be spending too much time on just the plain old trapezoid. What I want to focus on today is the souped up version 2.0 of the trapezoid, which is the isosceles trapezoid. Okay? What makes a trapezoid isosceles? Well, hey, it's still got 1 pair of opposite sides parallel. That won't change. But now the isosceles part, and you guys remember from doing triangles, isosceles means 2 sides are congruent. Well, on the trapezoid, same thing. The 2 sides that aren't parallel are congruent. All right, so the 2 sides that are not parallel are the congruent sides. And I do want to refer to them as their vocabulary term. They're called the legs. All right, so legs are congruent in an isosceles trapezoid. So everyone all right on an isosceles? What makes it isosceles before I get into two properties of an isosceles trapezoid? A pair of parallel sides, the non-parallel sides are congruent. All right, two properties about an isosceles. Only isosceles this works. Base angles are congruent. Base angles are congruent. All right, I'm going to turn this over to you guys. Let's say I name this isosceles trapezoid ABCD. I think you guys can do this. Guess what I'm referring to. What am I referring to when I say base angles? Give me a pair of angles you think are base angles in my isosceles trapezoid ABCD. Just take a guess because you're probably going to be right. Here we go. 7. St. John, what do you think I mean by base angles? Give me a pair.
The top angles and the bottom angles.
Both are correct. A lot of people just say, oh, A and D. Those are base angles. But there's another pair. B and C are also considered base angles. Okay, so there's two pair of base angles there. A and D are congruent. B and C are congruent. Any questions about that property before I get to the last property of an isosceles trapezoid?
Is this saying that all of the base angles are congruent, or the base angles across from each other are congruent?
There's two sets of base angles. Both are congruent. Each pair are congruent to each other. So I'm not saying all four are equal. I'm just saying each pair of base angles are congruent.
So angle A and angle D are congruent, but angle A is not congruent to angle B.
Correct.
All right.
Because if that was the case, I'd have a rectangle. Right? If all four were equal to each other. And the last property, isosceles trapezoid, diagonals are congruent to each other. So let me put A, B, C, D back up. Diagonals are congruent. So here you go. Diagonal AC for me would be congruent to diagonal BD. Diagonals are congruent. I get so fired up about this property. It doesn't seem like much. Here's why I get fired up. The diagonals are congruent. Guys, that's it. They don't bisect each other. They're not perpendicular. That is all you have is right here. That's it. Diagonals are congruent. That's it. That's it about the diagonals. A lot of, and they bisect. No, it's not. They don't bisect each other. This sucker's not a parallelogram. They're congruent. That's it. Discussion's over. Diagonals are congruent. Any questions on that property before we go into some algebra? Grab a calculator. Anybody questions on the properties? All right, let's do it. Find the value of the variables. Perfect. This is an isosceles trapezoid. You guys can see by my markings how I know it's an isosceles trapezoid. All right, find the value of x on number 1. I tried to suck you guys in by giving you a little bit too much information. You don't need all the sides there. Just give me what equation you're going to set up to solve for x. 1 zip. Atticus, here we go. Give me an equation you want to set up to solve for x.
X plus 5 equals 3x minus 3.
Yep, I didn't even need the x minus 1. It was just there to screw with your mind. Sorry if it did. Atticus just set the legs equal to each other. Legs are congruent in an isosceles trapezoid. All right, no issues here with the algebra, I hope. I get 2x on one side and I get positive 8 on the other. So x equals a 4 spot. Questions on that algebra one before we talk angles now? All right, let's move to 2. Everyone see isosceles trapezoid with the markings? Ooh, all right. Base angles are equal. Base angles are equal. Yes, you could tell me that angle of 6x plus 20 is equal to y because those are base angles. You guys know how I feel about that. We don't want an equation with 2 variables. Let's try to avoid that. All right, let's try to avoid using that. So what about these two angles that have x in them? 4x and 6x plus 20. Is there a relationship between those two? Let's dig deep here. Is there a relationship between that 4x angle and that 6x plus 20? And remember, lines are parallel.
Same side interior.
There you go. They are same side interior. Dun, dun, dun. Same side interior are supplementary. 4x plus 6x plus 20, 180. They're supplementary. They're same side interior. Has nothing to do with the trapezoid. Has everything to do with parallel lines. All right, let's get. Yep, go ahead.
You just mean like if you double 4x and you double 6x plus 20,
Yep.
all of that adds up to 360.
Yeah, that is another way around it. Correct. You could do 8x plus 12x plus 40 all equals 360. Absolutely. Yep. All right, so what do I got here? 10x equals 160. X equals, what am I looking at there? 16? All right, x equals 16, but I had a y in there as well. Need some help on finding y. I'll let you guys think about it and then I'll ask somebody. How can I find the value of y there now? Remember, base angles are congruent now. We just learned that it's a property. Base angles are equal. Thoughts here? Gideon, any way you want to find y? Going, Gideon, any ideas?
I forgot. I didn't know I was muted. You could do 16 times 4 plus y equals 180.
16. So you're saying that these two, the 4x and the y, are supplementary?
Yeah, or complementary, I think.
Well, complementary means they add up to 90. I don't think anything adds up to 90 here.
Oh yeah, supplementary. Yeah.
Okay, I think that would work. All right, pretty positive that would work. Another way around it is take your 16, plug it in for x, because I know in an isosceles trapezoid, base angles are equal. So I could just say y equals 6 times 16 plus 20. And then you guys should be getting y to be 116 degrees. Anything on those two before we get to an honors level 1 and number 3? Going? All right, find x. On number 3, find x. I can definitely tell already it's an isosceles trapezoid. Perfect. That's x. If that's 13, that's got to be 13. So I'll throw a 13 in there. Ooh. How can I find x? Ooh, this is going to be tough here. All right, let me help you. I'm going to try to split this trapezoid up into a rectangle and 2 right triangles. All right, right now I have a right triangle that looks like another trapezoid on the right. So what I'm going to do is I'm going to go to the other side here, and I'm going to draw in another altitude. So does everybody see that I have just broken this up into a rectangle in the middle and 2 right triangles on the outside? All good? And if anybody wants to know why it's a rectangle, let me know. I'll certainly easily prove that to you. All right, if that's a rectangle, if this top part is 24, I know the opposite side also has to be 24. With me so far? And remember, the 34 was the length of the whole base of the trapezoid. That was the length of the whole base. So that means I have 10 left over for these two spots. Right, this one and that piece right there of the base. I have 10 left over. And I wish I had more time. If you guys want to see it, let me know. Anybody want to make a prediction or maybe what they actually know about those two triangles on the outside? Anybody want to make a guess? What do you think I know about those two triangles other than they're right triangles?
They're congruent.
They're congruent. Yep, by multiple methods. HL, angle, angle, side, they are congruent. Both triangles are congruent, which means by CPCTC, these pieces are equal. And remember, I had 10 left over, 10 units left over. So that must mean each piece has to be 5 and 5. What do you think now? How can I find X now? There you go. I like a lot of people chiming in there. Love it. A squared plus B squared equals C squared. Yep. I got 5 as one of my legs. X is my other leg. And 13 is the hypotenuse for C. There it is. Little Pythag. Oh, geometry. Beautiful. Triangles were congruent. CPCTC to get to a little Pythag. Move the 25 over. I'm looking at a $1.44, right? Take the square root. X is 12. All good? Questions from you guys? That was fun, right? The algebra is always a good time. Get to use my calculator. Oh, I loved Algebra 1. But you know what's coming up. Any figure we do, yep. We got to try out some statements, reasons with it. So how do I show a figure is an isosceles trapezoid? Guys, go ahead and get your diagram marked up here in number 4. Get your diagram marked, ready to roll. You got, all right, AECD is a parallelogram. So I always like to highlight my parallelogram so I know what I can apply my properties to. And then I have 2 angles right here that are congruent to each other. Oh, all right. All right, you ready? Prove it's isosceles trapezoid. Look up above, right up above, guys. We have two different ways to prove a figure is an isosceles trapezoid. I'll let you guys read through that. Go ahead, read through the 2 different ways I could prove an isosceles trapezoid here. When you guys read the 2 ways, how did each way start? Look at both ways right now. How did it start? It's got to be a trapezoid first. So no matter which method we choose to do, method 1 or method 2, we still got to show it's a trapezoid first before we talk isosceles. Okay? So that is the first thing I'm going to do with you is let's prove ABCD is a trapezoid first. All right, then we can figure out if it's going to be isosceles. So first thing, prove it's a trapezoid. How do you do that? How do I prove it's a trapezoid? Look at above. There's only one way. There's only one way to prove a trapezoid. Give me a pair of opposite sides parallel and give me the other pair not parallel. That doesn't sound too good, but I'll get to it when it comes up. All right? So my first question, anybody get me a pair of parallel sides in ABCD?
DC and AB.
All right. Just by the looks, right, guys? We're going to get DC and AB to be parallel to each other. How do we do that? Whoa, 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 whoa. Don't chime in yet. Ooh, here we go. Back to St. John. St. John, if ECD is already a parallelogram. Give me two sides you already know are parallel.
DC is parallel to AE and DA is parallel to CE.
Okay, so DC parallel to AE, and I'll write it both down, whether I need it or not. DA parallel to CE. I'll write them both down. Yep. And that's because parallelogram implies that, hey, opposite sides are parallel. All right, so I know DC and AE have to be parallel. I gave you guys a theorem before break that said, hey, AE is a part of AB. So why doesn't that mean that, why shouldn't DC also be parallel to AB? I'm just making it longer. I'm just making AE a little longer. What gave me the right to do that? We had a theorem for that that says, hey, if you want to make it a little longer, you can, and they're still parallel. Anybody remember the wording for that one? 5 spot. Hayden, you remember the wording for that one?
No, not really.
Okay, it began with an E, X, making it longer, T, E, N. Got anything?
Extensions of parallel lines are parallel.
Got it. Extensions of parallel lines are parallel. Boom. So I got one pair of opposite sides parallel. You got to prove the other pair are not, though. Okay, you have to prove the other pair are not parallel. Oh boy, how am I going to do this? Some of you I know are on top of your game. You might be thinking, oh, do we have to do an indirect proof as part of this? No, you don't. No, you don't. Here's what I need. I got one pair parallel. You have to show me the other pair, DA and CB, are not parallel. Look, I just put the little slash through there. Are not parallel. This is the worst time of the year for me right now. I get so embarrassed with what I'm going to have you guys write down. This is going to be the most non-mathematical thing I will ever have you write in a proof. Are you ready for my reason why they're not parallel? Well, what do you guys know about parallel lines? They never intersect, right? Parallel lines will never intersect. But if you took DA and CB and kept drawing them out, what's going to happen?
They'll intersect.
They will eventually intersect. Oh, I hate doing that, but it's 100% correct. That is not mathematical at all. Oh, my heart. They will eventually intersect. Oh, I feel gross. All right, nothing fancy. That's all I need there. The other pair is not parallel because they'll eventually intersect. So now you have a trapezoid. Not isosceles yet. Not isosceles. Just a trapezoid. So ABCD is a trapezoid. I'm going to turn this over to you. I want to make sure you guys are following along here. How do I know it's a trapezoid? What did we just show in the proof that made it a trapezoid? Use your own words, nothing fancy. Use your own words. 1, 3. Here we go. Sophia, in your own words, why is this a trapezoid?
One pair of the opposite sides are parallel, but the other one isn't.
Perfect. Perfect. One pair of opposite sides parallel, and the other pair is not. Implies trapezoid. Perfect. You have to show the other pair is not parallel to make a trapezoid. All right, now let's keep going. How do I make it isosceles? Go back, look at your two reasons now. I have a trapezoid. How do I turn a trapezoid into isosceles? I got two options, and both options we can do here. both options are possible in this proof. I could get the legs congruent, or I could get a pair, only one pair of base angles congruent. We can do both. It's just a matter of what we want to do as a class. We can get the legs congruent, or we can get a pair of base angles congruent. It's up to you. Somebody's going to pick for the class right now. 1, 2. Here we go. Lucas, what would you prefer here? Legs congruent or base angles congruent?
Base angles.
Okay, base angles. So I need your help, everyone in class. I need your help getting angle B congruent to angle A. I need your help. Get angle B and A congruent because those are the base angles we're going to need. So based on what I just gave you here, how can somebody get me B congruent to A? Well, it's not going to happen right now. I can tell you that. It's not going to happen in step 6. But you could tell me, ready? Angle CEB is going to be congruent to what? CEB. CEB congruent to, little help, 2, 4, going deep. Emily, you see another angle that would be congruent to CEB? Other than angle B, because that was given, but.
Angle ECD.
ECD. Oh, you got me there, Emily. Son of a gun. Not the one I wanted, but you are 100% correct. I can't blame you there. Yes, that angle right there, because they're alternate interior, got me, Emily. Son of a gun. Nice job. All right, I was looking for another one, though. Anybody angle A? CEB is equal to angle A. Chime, what type of angles are those? CEB and angle A. Those are 2, 3. Luke, what type of angles do I have there? CEB and angle A.
Corresponding.
There you go. And I already have the parallel lines in step 2. Step 2, I already told you the lines were parallel. So parallel lines imply corresponding angles congruent. And you could have went with Emily's angle too and then just said opposite angles are congruent. Substitution, you could have done it that way. Okay.
How is it corresponding angles? I'm sorry.
Yep, here you go. Let me highlight the parallel lines for you. I know I'm making a little bit bigger of a mess. Ready? DA. There's angle A with CE. There's that angle. See how they're corresponding with this?
Oh, I thought we were talking about angle CBE. Sorry.
With that transversal there. Okay?
All right, thank you.
Yep, no problem. All right, let's wrap this up now. Now I know angle A and B have to be congruent by a little thing we've used multiple units called 1, 6. Kyla, can you put it together? Why would A and B now be congruent?
Substitution.
You got it. And if you guys want to know where that substitution comes from, it comes from step 6 and the given. Okay, step 6 and the given. All right, I got a pair of base angles congruent. It's isosceles now. So last step, ABCD is an isosceles trapezoid. And I'm going to look to turn to you guys one more time to tell me why is it isosceles. And here's a hint. I need more than base angles congruent as your reason. I need a little bit more than base angles congruent. Here we go. Audrey, in your own words, why is this an isosceles trapezoid now?
Because 2 base angles are congruent.
Need more.
Trapezoid work.
Okay, need more than the base angles are congruent. It's
Can you prove it's a trapezoid too?
Okay, no, yeah, we just did that, right? So add that in, that it's a trapezoid with
2 base angles congruent.
there you go. Have in there that it was a trapezoid. Because I could give you a 4-sided figure where 2 of the angles are congruent. It wouldn't be a trapezoid. All right. Trapezoid with base angles congruent. Good job. I do just want to go back. I told you that you could also prove the legs congruent. Here you go. If anybody chose that path, remember these two angles were given congruent. In a triangle, congruent sides are across from congruent angles. It was a parallelogram as well, so CE and DA would have been congruent. So then I could have said by substitution, DA equals CB by substitution. All right? So that's how I could have gotten the legs congruent instead of the base angles. Either way would have worked. Questions about that proof at all? So you have to prove it a trapezoid first. And everybody's good on, because this is probably where I'm going to end it today. I don't have time to go on to the other stuff. Prove it a trapezoid. You got to show one pair parallel, and yes, you have to show the other pair are not parallel. That's what has to happen for a trapezoid. Anything you guys want to ask here before we call it a day?
Will your reasoning for something not being parallel always be something along the lines of they will eventually intersect?
Sophia, in a statement's reasons, yes. If you're doing a coordinate geometry, show they're not parallel by showing their slopes are not equal. Okay? All right, guys. Have a good one. Remember, there's more than just trapezoids tonight for homework. Pay attention to the detail. I'll see you tomorrow. EG. Hello, Liz. Hello, Colin.
Test. Station achievement.